Hey guys, today we're going to talk about principal inverse values, and basically they're the same thing that we learned before, but we are going to use the graphs, the function graphs of the inverse parent functions in order to find the one answer, the principal inverse value. So I just want to remind you of what all of our inverse graphs look like. You don't have to draw these as long as they're somewhere in your notes already. So we have the inverse parent function for sine, and the big thing to notice about this is that your x is your ratio, right? It goes, you'd have your 1/2, your √3/2, whereas y, the value that comes out of this equation, is going to be an angle measure. So on this graph, if you can't see, it goes from -π/2 to π/2. So the important thing that we need to know about this graph is that the range goes from -π/2 to +π/2. Okay, same deal with cosine. Still going to have your angle measure on your y-axis, and the range on this guy, it goes up from 0 to pi. And you can include those values because remember, this is actually, the sine of 0, or sorry, the cosine of 0 is 1, etc. Okay, now tangent, remember, tangent had those funny looking asymptotes on it when I flip-flopped it over. So it's going to have the same range as sine, the inverse sine, except for I can't include those points. My graph is getting really, really close to those π/2s, but it's never going to touch it. So when I look at this, remember there's arrows at the end of this one. And then we look at my inverse, or my reciprocal inverses, there we go, and they have very similar ranges. The only thing that's different about here is they also had asymptotes just like the tangent graph did. So the range on this one is going to use some numbers we are familiar with, and that is the -π/2 to π/2. However, there's a gap in the middle. So there's a 0 where we can't have anything, but we are going to continue and go back up to π/2 up here. Okay, same deal with secant. It's just now my asymptote, that little gap, is going to be at π/2. So we're going to go from 0, we can't include 0, up to π/2, don't include it, then we start my graph back up again, and we end at pi. So if I'm looking at my endpoints here, we kind of see a pattern going on. We have -π/2 to π/2, and then we have 0 to pi. Okay, finally we have inverse cotangent, and again, it has those asymptotes at the top and the bottom, which is nice because that just means my range is then 0 to pi non-inclusive. So we use the parentheses. Okay, so those are the ranges for these graphs, and those are also what we call the restricted range to find a principal inverse value. So restricted range, basically what you're saying here is this is how we made my graph a function. Okay, we had to restrict the range. So when I'm looking here, my restricted ranges, we had the -π/2 to π/4. Sorry, I lost my pen there for a second. Okay, that was this inverse sine function, the inverse cosecant function, and the inverse tangent function. So ka, toa, but not with a ka, right? And so when I look at that, if I'm going from -π/2, which is down here, up to π/2, if I had a positive value, so if I was looking at, for instance, 1/2, the inverse sine of 1/2, I'm going to put my angle in quadrant 1. But if I have a negative value that has a negative y value, I'm going to go down here into quadrant 4. And really in quadrant 4, it's just the negative reference angle. So it makes life a little bit easier. You just have to think about, if I knew the reference angle was 60 degrees, I'm going to make it -60 degrees. Okay, my other set of restricted ranges went from 0 to pi in some way, shape, or form. And those are cosine and its inverse, secant, and then cotangent. Cotangent is just kind of funky. And this one, if you're positive, you're still going to be in quadrant 1, because 0 to pi looks like this. So we're still going to be in quadrant 1 if I have a positive, but then if I have a negative x value, it'll make my ratio negative, so I would be in quadrant 2. If I try to go down in quadrant 4, those those two functions would still be negative, so it'd be weird, or positive. Oh, sorry, I'm struggling with words apparently. So if you can remember these two things, that sine, cosecant, tangent go together, and they're in quadrants 1 and 4, and that cosine, secant, cotangent go together, and they're in quadrants 1 and 2. This is really simple. Okay, it's the same thing that we've been doing, but we're only going to have one answer this time. Okay, it's kind of what your calculator was finding for you yesterday when you typed in the inverse. It only popped out one answer. not the second part. That's what we're looking for here. So if I look at the number 1, the inverse sine of -1 over the square root of 2. Since it's negative and it's a sine function, I'm going to draw this angle in quadrant 4. Normally I could also draw it in quadrant 3, but because they didn't say give me them from 0 to 2 pi, they just said here's my thing, you are going to find the principal inverse value. And we're going to go ahead and draw my angle in quadrant 4. Okay, so I know this is going to be opposite over hypotenuse. And if I know my special right triangles, that means that this side is also 1. And this would be a 45-degree angle. So in radians, that's pi over 4. And since I'm going to be in between negative pi over 2 and pi over 2, I don't have to go all the way around the circle. I just take my reference angle and I make it negative. And that would be my principal inverse value for this particular ratio. Okay, same deal for cosine. Okay, when I look at this guy, I have the inverse cosine of negative root 3 over 2. Since it's negative, I go think about that and I say, okay, well, cosine has got to be in quadrant 1 or 2. It's from 0 to pi. So I'm going to be, since it's negative, quadrant 2. And I'm going to draw my angle. That's a terrible triangle. It's okay. So I know that this is adjacent. So root 3, and it's negative because my hypotenuse has to be positive. Then I look, and this other side would have to be 1. That makes this a 30-degree reference angle. So this is the one that gets a little bit harder because I have to figure out all the way over there. But this should be a pi over 6 reference angle. And I know if I'm right here next to pi, or 6 pi over 6, this has got to be 5 pi over 6. Okay, so really the hardest part about these is remembering which quadrant you're going to stick your angle in. So right here, we have the inverse cosecant of root 2. So this is positive. All of your inverse values, if they are positive, are going to go into quadrant 1 first. That's the first place that we start, so we're going to throw that in quadrant 1. Cosecant, I know, is going to be the opposite of sine. And since it's the opposite of sine, it would be hypotenuse over opposite. So since it's reciprocal, it's the flip-flop, I have my hypotenuse as root 2. And remember, I can always write this as over 1, so that means my opposite side is 1. Then I can fill in the last part of my triangle. This would be 1 also, because this is root 2, 1, 1, if I did my Pythagorean theorem. And I know then my reference angle would be a 45. And so if I write that in radians, just pi over 4. So really, the principal inverse values are nice because they're just 1 step instead of 2 steps. Okay, last one that I have here, I have the inverse cosine of 0. Remember, if you see this, this is not asking you to find what is the x value at 0 degrees. This is asking you for an angle measure. What angle will give you this particular ratio? So again, I'm not going to draw a triangle on this one because what? That's a 0. That's terrifying. So what I'm looking for, since this is cosine, I want to know where my x coordinate is equal to 0. Okay, so I also have to look in my restricted range. So when I'm thinking about this, remember, my cosine has to be between 0 and pi for my inverse cosine. So if I can do 2 things. I can think about my unit circle. And again, I don't care about down here. We're not going to use quadrant 3 or 4 for this portion. So if I'm thinking about where my x coordinate is 0, that's only going to be here at pi over 2. So that would be my answer. The other thing I could do is I could do my OIO chart. O-I-O-I-O-U. Oh, I don't owe you. And then we have 0, pi over 2, pi, and 3 pi over 2. And again, I'm looking for the value within this 0 to pi range. So I can pretty much forget about this when I'm finding the principal inverse values of cosine. So I look here. I have 0, cosine is 0 at pi over 2, so I get the same answer both ways. So again, the big difference about principal inverse values is you only have 1 value that you're going to find, not 2, only 1, and that you've got to stay within that restricted range that we saw on the parent functions yesterday. So you've got to remember where all of your angles go. So on, well, my mouse is being silly. So on here, knowing that sine, cosecant, tangent fall between negative pi over 2 up to pi over 2, and that cosine, secant, and cotangent fall between 0 and pi. And that's all I've got.